If you've spent literally any time using AI to write code recently, you absolutely know the feeling. You ask an AI for a feature, it spits out this fragmented snippet of code, and suddenly you're playing this chaotic game of copy-paste, just trying to figure out how it fits into your broader architecture. It's kind of like the Wild West out there with unstructured AI prompting. But what if we could actually bring some order to all that development chaos? Welcome to this explainer, where we're going to dive into a seriously fascinating tool called Skill. It's designed to completely standardize your AI delivery and transform how you manage AI agents right inside your repositories. So the big question we're tackling today is this. How do you actually standardize AI coding? Like, how do we move away from random chat windows and scattered prompts and get into a structured, reliable, and repeatable engineering process? We really need a system that treats AI not just as some fancy autocomplete, but as a coordinated team of developers. And well, that brings us directly to our solution.
Okay, here's our roadmap for this explainer. First, we'll meet Skill. Second, we'll look at domain-driven design alignment. Third is the core agents bundle, followed by the 4 AI roles, and we'll wrap up with the spec to ship workflow.
All right, let's jump right into part 1, meet Skill. So, Skill operates as a command line interface, or CLI tool, and the name perfectly represents what it actually delivers: agent skills. Think of it as the ultimate factory floor manager for your multi-agent AI coding. Instead of relying on some third-party platform that, let's be honest, doesn't really understand your specific project, this tool lives directly inside your repository. It installs reusable skill packs and production-ready agent templates right where your code lives, whether you're using Copilot, Claude, or Cursor. Moving right along to Section 2, Domain-Driven Design Alignment. You know, most AI tools just spit out these scattered code snippets based on whatever immediate prompt you just fed them. But Skill, it's deeply rooted in actual software engineering best practices. It explicitly supports domain-driven design-aligned core agent bundles. Basically, this means it organizes your AI agents around your specific business domains and aggregates, which ensures that your architecture stays sound, decoupled, and scalable. It's literally forcing the AI to think about the structural integrity of your software, rather than just hacking together a quick fix. Next up, Section 3, the Core Agents Bundle. To get started, you just use a super simple command right in your terminal. By running skill add core-agents, you're installing a templated agent team directly into your repository. But here's the brilliant part. It's stack-aware. By appending flags like -backend Python and -frontend React, Skill dynamically scaffolds templates that are perfectly tailored to your exact tech stack. It doesn't just give you a generic agent, it gives you an agent that actually knows how to write Python and React. Now, if you just run the basic command without any flags, the default stack pairing is .NET for the backend and React for the front end. But you've got some fantastic variants available. You can easily swap that backend over to Python, Java, or Go. So to put that into perspective, whether you're working at a massive enterprise Java shop or a super modern Go startup, Skill seamlessly adapts its AI agents to speak your repository's native language. All right, let's hit Section 4, the 4 AI roles. When you install that Core Agents bundle, you aren't just getting one generic AI assistant. You are scaffolding an entire production-ready AI team. The bundle gives you 4 highly distinct templates: the Ag Architect, the Ag Coder, the Ag UI Developer, and the Ag Tester. By breaking the whole development process down into these specialized roles, Skill makes sure the AI stays hyper-focused on just one task at a time. And trust me, that drastically reduces hallucinations and massively improves the quality of the output. Let's contrast these roles for a second to see how they actually interact. First up, we have the Ag Architect. This is your master planner. Its sole job is to look at your requirements and design the domain-driven design aggregate and the overall system structure. It doesn't write the final code at all, it just writes the blueprint. Once that blueprint is good to go, it hands it off to the Ag Coder. The coder is your back-end execution specialist. It takes the architect's design and implements robust back-end logic using whatever stack you chose: Python, Go, Java, you name it. Building on that, we round out the team with the front-end and quality assurance roles. The Ag UI developer steps in to handle the user interface, generating your React components and making sure they wire it perfectly to the back end the coder just built. And finally, the Ag tester steps onto the scene to ensure quality through validation and testing. It acts like an independent reviewer, catching bugs and edge cases before you'd ever even think about merging the code. It's a true multi-agent assembly line. Which brings us to Section 5, the spec-to-ship workflow. The real secret sauce to standardizing this entire process lies in just one single file: workflow.md. When you install the Core Agents bundle, AG Skill automatically drops this core specification document right into your target agent directory, like, for example, your .github/agents folder. This file is the absolute blueprint for your client project. It tells both you and the AI agents exactly what the sequence of operations is, making sure no steps are skipped and that every single agent knows exactly when it's their turn to step up to the plate. Let's quickly walk through this inherently chronological assembly line execution because it's pretty cool. First, you define all your requirements in your spec, anchoring everything in that workflow.md file. Next, the ag architect takes that spec and handles the design phase, mapping out all those DDD aggregates. Once the design is locked in, we move right into the build phase, where the ag coder and ag UI developer get to work, either in parallel or sequentially, to write the actual software. And finally, the ag tester validates the work so you can ship it with total confidence. It literally transforms AI coding from a chaotic chat window into a totally predictable, engineered pipeline. And before we finish up, a quick bonus section: token observability. Look, we all know AI tokens cost money, and unmonitored agents can run up a massive bill if you aren't paying attention. Well, AG Skill includes built-in token observability. It estimates or extracts exact token counts depending on if you're using VS Code Copilot Chat or Claude Code. And the best part? All that telemetry data stays securely in your repository inside a local JSON-L file. No external service phoning home, no privacy concerns. By just using simple CLI commands like observe, stats, and dashboard, you can pop open local HTML reports to see exactly how many tokens your ag architect or ag coder chewed through on their last run. We have covered a massive amount of ground today, from domain-driven design bundles all the way to multi-agent spec-to-ship workflows. By using a tool like AG Skill, we can finally stop treating AI as a novelty and start treating it as a structured, reliable part of our engineering team. So my final question to you is this: how are you going to use AG Skill to standardize your repository's AI workflows? If you're ready to bring some order to the chaos, you might want to pull up your terminal right now and run UV-tool install AG Skill to try it out for yourself. Thanks so much for joining me on this explainer, and hey, happy building!